Hello students. In the last session we have discussed about the serial in and serial out, serial in and parallel out we have discussed. In the counters we have discussed. In this session I am going to explain about the parallel in serial out. Parallel in serial out for a register with the parallel data inputs means that one in yesterday's session I have explained about this one. The parallelly the data is enter and serially the data will out. This is the way can be expressed. It is in the parallel in and the serial out. The for a registers with a parallel data inputs, that bits are entered simultaneously into their respective stages on a parallel lines rather than on bit by bit is basis on the lines as with the serial data input. Whatever the bits you can use that one, it is can use that 2-bit data, and sometimes you can use for that one in the 4-bit data, 3-bit data. It depends on the how you are giving the inputs. And next slide illustrated the 4-bit parallel in serial out shift registers. Shift registers and the load is means applied in the clock. It is the load. Yes, I am going to express in the circuit wise. I am going to express. This is the way can be expressed like that one. It is the parallel data enters into this one. This is the clock, and this is a shift, and this one is a output, serial out. This is the input. I am going to give that one. This is the way can be expressed. Notice that there are the 4 data inputs are there: D0, D1, D2. Shift or a load inputs which allows the 4-bit data into the load in parallel into the registers. A parallel a parallel data enters for that one. Parallel data is entering like the parallel data load means load in and load to load out. Yes, then the clock use the data clock to used in the total processing, means n minus 1 clock can be used. N minus 1, it is a n minus 1 data can be used. Clock use the data n minus 1, it is a 4-bit data can be used. The 4 minus 1 of the clock is used for that one. Yes, can be expressed in this one. When the shift or a load in a is a low gates, G1, G4, G1 through G4 are unable to allowing the data bits. I am going to express this circuit. D0, D1, D2. D0, D1, D2 and D3 are the inputs. Shift or a load. Yes, this is a shift. This is a load. Are you getting my point? Enter of the input is a shift, and after that inverting it is a load. Can be enter for that one. I am going to enter this load. I am going to first give a clock high. Clock high means it is a positive transition. Positive transition means low to high. Clock is 1. Yes, first one. I am going to give that one 0, 0, 0 first. First I am going to give the 0 here, and 0 is here, 0 is here, and the 0 is here. Clock is first clock I am going to give it in the 0. First clock I am going to give the 0. Inverting of that 0, 0, 0 into the 1, 1, 1 will come. D1 1, D2 1, D3 1, D4 1. Inverting of that one. Yes. First I am going to give that one. This one. Yes. Now it is a 0. AND gate. 0 into 0 is a 0. Obviously the 0 into 0 for that one. This is the clock will come here. It is a 0. 0 enters here. This is also a 0. 1 into 0 is 0, 0, 0 comes here. This 0 is goes to here. ಕನ್ನಡದಲ್ಲಿ ಹೇಳಬೇಕಂದ್ರೆ first I am going to give the 0 inputs. Inverting of 0 is 1. Correct? Clock is a 0. Clock is enters here. Here the 0 and the 1. AND gate 1 into 0. It is a 0. Right? Just note this point. Next, this 0 is enters here. This input goes to output. It is a 0. This 0 enters here and clock is 0. It is a 0. 0 into 0. 0 into 1. Clock is 0. D1 is 0. Just a minute. Just a minute for that one. D1 I am giving shift or a load. I am giving 0, 0, 0. First I am going to 0. D0 is 0. D1 is 0. D2 is 0. D3 is 0. All are zeros. Just enter here. Next, I am going to give that one. Clock is 0 and this is 0, 0. 0 plus 0 is a 0. The output of Q1 is 0. Next, this is a 0. Clock is 0. Input, this input is 1. And this D2 is 0. Here the 0. 0 plus is a 0. 0 here comes. This shift to Q2. Q2 is 0. Clock is enters here. 0. D3 is 0. But this shift is a 1. 0 into 0. It is a 0. The serial out is 0. Yes, all Q1, Q2, Q3 are zeros. D1, D2, D3, D4 are 0. Means that one. I am going to write it 0, 0, 0, 0. D0, D1, D2, D3 equals to 0. Q0, Q1, Q2, Q3 is also 0, 0, 0, 0 will come. Yes, this is the first set. First set of that one. Next, I am going to give the positive transition for that one in the shift registers. Yes, first is a first shift. I am going to give that one. I want to give a 0 here. 1 is a clock. This is a 1 will come. D0 1, D1 1. Yes, D2 is 0 and D3 is 0. Yes, this is a 1 and this is a 1. Clock is also 1. Clock is also 1. This is the output is 1. 1 is here. This comes here 1. 1 is a clock. Second clock. I am going to change the colors for that. This 1 is enters here. 1. Clock is 1. 1 will come. This is a 1 and this is a 1. 1 plus 1 is a 1 will come here. This enters to 1. 1 is here. clock is 1, 1 will come here. This is a 0, this is a 1, this is a 0. Yes, this is a 0. Correct. Next cycle I am going to take that one. Next cycle I am going to take this one is this is a 0 and a 1. It is a 1 comes here. This one goes like that one. Clock is a 1. This is the 1. Clock is 1. This is a 0 and this is a 1. 1 plus 0. 1 is here. 1 is in the shift registers. This is the 1100's output is 1111 will come for that one. Shifting in the parallel. Yes. Next I am going to take that one. Next I am going to take that one. Clock in the negative transitions. Clock in the negative transitions. I am going to take that one. It is a 0. It is a 1. Shift load is a 1. Yes. Next I am going to take this one as a 1, 0, 0, 1. Here the first one I am going to first give it as a 0. 1 into 1, 1 comes here. This is a 1 is enters here. Clock is 0, 0. This is the clock is, this one is a 0 and the inverting is 1, 0. 0 into enters here 0. Clock is a 0. 0 comes here. This is a 1 and 0, 0. 0 will come. 0 is comes to here. And this is the in the output. It enters here. Clock 0. Here the 0. This is the 1. This is the 1 and this is the 1. 1. 1 comes here. 0 into 1 plus is a 1. 1 in the 1 means D0, D1, D2, D3 equals to 1001. Q0, Q1, Q2, Q3 is 1001. When the clock is in the negative transitions, it is a 0. Clock is 0. That it comes like that one. I am going to explain about this parallel in and the serial out using the combinational circuit for this one. Using the combinational circuit by using the 4-bit parallel in and the series out. I am going to take the one more example for that one. Shift is a 0. Clock is 0. This is the 1. Next I am going to give the numbers. 1 1 0 0. 1 1 is a 1. There is no clock for that one first cycle. That wise clock is n minus 1. I have told. This enters here 1. Next cycle. This 1 enters here and this is the clock is 0. 1 into 0 is 0. This enters here 1 1 1. 1 comes here. 1 is here. This is the output 1. Next this enters to 1. Clock is 0. It is a 0. This is the 1. 1 into 0. 1 into 0 is 0. It is a 0 comes here. 0, 0 enters here. Next clock I am going to give that one 0 into 0. 0. 0 into 1. 0 into 1. 0. This is a 0. The serial out means 1100 equals to 11 output 00 will come. This is the way of the clock is 0 when it comes like that one can be expressed in the parallel in and the serial out mode. Okay, it is a 4-bit flip flop, can be 4 flip flop, D flip flop can be used that one. Whatever the input comes, it is in the QN can be shift to the registers. It is in the clock for that one. Clock is giving. It is a shift or a load. Shift or a load. 0 comes here. If you want to give the 0 here, it is a 1 comes here. Here it is a 0 na. Correct. It is a 0. 1 is comes here. 1 1 1 1 here comes. It is a 1 into 1 1. 1 is comes here. This is goes to here 0. 1 into 0 is a 0. 1 into 1 is a 1. 1 comes here. 1. This one is enters here. And 1 into 0 is a 0. 0 comes here. 1 into 1 is a 1. 1. 0 plus 1 is a 1 comes here. This shift to here. And then it is goes to here. 1 into 0. It is a 0. 1 into 1 is a 1. 1 comes here. It is, sorry, 1 comes here. 1 comes here. It is a output. 1111 of the shift register is 1111. It is a clock pulses are here. This is a clock. It is a high clock. Clock is a high. This is a clock is 1. 1 into 1. It is a 1. 1 into 1. 1. It is the 1 into 0. And the clock is 0. It is the 1. It is 0. There is no change of that one. 0 0 0 will come. If it is a clock is high, then only this circuit is working. Otherwise, there is no importance of the gates. This is a clock. Sorry, before that one I have told that one clock is here. It is a shift or a load. Load is applying here. That is the then it can be shifted. Okay. Next is a parallel in and the series out. This is the circuit for that one with the explanation they have given. Next is a parallel in and the parallel out. Parallel in and parallel out, this is the data. This is the clock pulses. I'm going to give that one. D flip flop, how does this work for that one? The parallel in parallel out registers employs both the method of immediately follow the simultaneously entry all the data bits. The bits appear on the parallel outputs. Means I'm going to explain this in the block diagram. This is a parallelly enters the data, the parallelly out in the datas. Yes, if you are giving, it will out like that one. Yes, this is the way to express in the data. Yes, next is that one. D0, D1, D2, D3 can be expressed parallel in, parallel out. Here it is a out. This is the parallel out. Yes, it is a parallelly enters here the data. It is a parallelly out the datas. That is the parallel in and the parallel out of the registers counters. The shift registers are enters to here. First I am going to give the data for that one. Then I will explain it. First I am going to give the clock is 0. First I am going to give the data is first I am going to check that one. This register shift register is working. That's why I am entering to the reset that one. Yes, this is a enters here. 0 will come and 0 0 0 will come for that one in the output. Obviously clock is also a 0 using a D flip flop, right? That is a 0. Next I am going to give the data. Next I am going to give the data for that one. 1 1 0 1. I am going to give the clock given that one. Just I am going to explain once again about the D flip-flops. D flip-flop can be expressed that one. First, I'm going to express about the D flip-flop. Clock is high. D is 0 and 1. Output of next is, if it is a 0, 0. If it is a 1, 1. Clock is high. 0 is a 0 resetter. 1 is a 1 set. It is a D flip-flop. Once again I am going to explain. Next I am going to explain about this one. 1 1 0 0. 1 is a D. Clock is a high. Obviously the output is set. 1 is a here. Clock is a 1. 1 is a output. This is a output. 0 is a clock is high. The 0 comes reset. 0 0. Yes, whatever the giving the inputs for that one, it will out. First I'm going to give that one in this 1 1 0 1. There is no connect between the one flip flop to other flip flops. That is a thing is here. One is giving to here, one is clock is here. It is a 1. 1 and 1 is a 1. 0 is a 0. 1 is 1. This is the way to express in the parallel in and the parallel out circuit. This is the way to express in the, yes, in the circuit of the using the 74174 IC can be used in the parallel in and the parallel out. Here they have given the out input and the output can be see that one. Parallel in parallel out 74LS174 is a data sheet is given set up the 20 nanoseconds and the hold inputs for the 5 nanoseconds. The minimum required width of the data is input level is D1 to D6. This is the way. Parallel in parallel out it is can be used in by this circuit. I am going to whatever that one simplify that one we have expressed. The mode of the control in the serial inputs is here. The clock of the shift register is here. And we are using the combinational circuit for this one in the parallel in and parallel out. With the different ICs can be used for that one. I am going to explain about the parallel in series out. You have seen that one. I am going to tell the um clock of that one. Graphical representation I am going to express. You have know about this one. Once again I am going to explain. If it is a 0, 1 1 0 0, it is there. 0 is here. Clock is high. Whatever it comes, it will come out. D1 D naught is 1. The clock is 1 here. 1 will come. Clock is 1. Output is 1. Next, this one is enters to here. This clock is a 0. It is a 0. 1 into 1, it is a 1. 1 plus 1, clock is 1. Output is 1. Next is this 1 enters here. 0 is here. 0. 0 into 1 is 0 into 1. It is a 0. 0 comes here. Clock is 1. It is a reset. This enters here. This is the 0 into 0. 0 into 1. 0 0. 0 is a 0. 1 1 0 0 of the output is 1 1 0 0. This is the input and the output. I am giving to clock is here. This is the first clear that one. Low means it's a 0 ಮಾಡ್ತೀವಿ. 0 ಮಾಡಿ it is in the constant. Data A and B. Data A and B, I'm going to give that one 0 0 1 1 0 1 0 1 can be given like a two datas high low high low. Yes, B is a low high can be used. Clock is a 0 1 0 1, I'm going to give that one. QA is a 0, QB is 0, QC is 0, QD is 0. After shift that one, after shift that one, 1 0 1 1, it is shifting that one. Next is a 1 is shifting 1 0 1 1. 1 is shifting like that one in the serial in serial out 0 1 0 1. Like that one, it is the continuous of the, it is the shifting the output. This is the way can be expressed in the serial in and serial out graphical representation. Yes, here you can see that one. Serial in, serial out. This is a parallel in, serial out can be expressed. Explained about this one in the clock pulses. In that, I'm going to explain about this one. Parallel in, serial out. Explained about this one. This is a clock pulses. Clock pulses are high, low, high, low, high, low, high, low. This is the clock pulses. Next, it is the shift. Shift, always I am giving the 0. Always low. Right. If I want to give the A is high, B is 0, means first I am going to give the 1. 1 is here. 1 is here. A the 1, I am going to give 1. B is also 1. C is also 0. D is also 0. I'm giving that one. What will be the output will come that one? What will be the output? High, low. A is high, B is high, C is low, D is low. Yes, this is the way expressed in the parallel in and the serial out can be expressed. Yes, one more time I am going to express. This is the clock pulses, high, low, high, low. A is high, B is 0, C is 0, D is high. Q naught is high, Q1 is low, Q2 is low, Q3 is in the third clock will high. The third clock will high. 1 and 2 is low. The third clock will high. This is the way of expressing the clocks. In the parallel in and parallel out, you have studied about this one. This is the clocks are clock pulses. Can we see here? parallel in and parallel out can be expressed. It is a clock is, I'm going to give this as a clock. A is high, B is high, C is D are low. Q naught is high, Qn is low, means that one I'm going to explain with the different colors. Q naught of this one is Q naught of this one is high, Q1 is height here, Q3 is low, Q4 is low. Can be expressed as it this way in the clock pulses. Yes, this is in the parallel in and parallel out can be expressed. Applications of the shift registers are the ring counter can be expressed. Applications of the shift registers are used in the count the numbers pulses entering into the systems. Ring counter or a switched tail counter can be used. Yes, shift register can also generate a prescribed sequence in the respectively the particular sequence. Serial adder one is such as the application discussed in the next sessions. Okay, thank you. Please watch our videos regularly.